I've covered the concept that the Earth may not have an iron core, that the seismic waves could be interpreted in a totally different way. As it stands, there is no hard proof either way. We also recently covered the concept that the Earth formation process may have been much quicker than first thought, and this paper uncovered the uncomfortable truth that the iron content of the majority of the meteorites do not match that of Earth. In a new study, some scientists are now suggesting that heavy iron isotopes have been leaking from the core into the mantle, and that the light isotopes remain trapped inside the core. Let's take a deeper look at this story. In a new study, scientists have run experiments in the lab to see what happens to iron under the conditions that they think is equivalent to those in the Earth's core. In their studies, they discovered that heavy iron isotopes migrate towards lower temperatures, while the lighter ones do the opposite. They therefore speculate that this might cause the heavier isotopes to leave the core and infiltrate the lowermost mantle and enrich it with heavy iron. They therefore speculate that this might explain why the mantle's isotope ratio is much higher compared to the majority of the chondrite meteorites. They believe that this may have been happening for billions of years. Using computer simulations, they were able to show that this material could even reach the surface through the mixing with hot upwelling mantle plumes. Some lava eruptions at oceanic hotspots such as Samoa and Hawaii are enriched with heavy iron isotopes, which they propose is a signature of a leaky core. So let's just recap what we know and don't know. There is no concrete evidence that the Earth has a core at all. The seismic data can equally be interpreted to suggest it is hollow. In fact, in some senses, it actually fits the data better than a liquid and solid core model. The fact that the primordial meteorites, for the most part, do not match the iron ratio of Earth is a problem for the currently accepted formation theory. We detect heavy iron isotopes in the mantle plumes and in rocks. Add into this that we see a high percentage of heavier water isotopes on Earth, Mars, and the asteroids and comets compared to the gas giants and water giants. Is there a connection between these things? I see that there are 4 possible alternative ways to explain this. Some require a simple mechanism that can occur during electrical discharge. This can cause elements to change, more specifically for protons and neutrons to be added or stripped away. We see the evidence for this in the SAPPHIRE experiment, where a variety of elements were produced while only hydrogen was present. If we assume that the Earth is electrically driven, and that potentially this current is driven through the core and the inner part of the mantle, could arcing be taking place in certain regions which is causing the heavier iron isotopes to be created? The temperature at these zones would be higher, and then the iron would move to the cooler parts, just as the study found. An alternative explanation would be that a catastrophic event in the past caused massive arcing to occur on the surface of the Earth, and in the process created heavier iron isotope ratios. Some of these arcing events could have caused surges deep into the crust and mantle, and that these surge paths would later become easier routes for magma to escape upwards, and are now what we see as mantle plumes. The third scenario is connected to Eugene's ultra-deep biosphere. Could it be that some of the microbes are capable of producing iron as a sort of byproduct of their existence? There are actually microbes that are able to produce certain iron compounds as a byproduct, but these obviously do not produce the heavy iron. Is it possible that there are strains that exist deep down which are able to produce heavier isotopes? The fourth scenario goes back to what I discussed in the alternative Earth formation video. At this stage, we really do not know how planets are formed, and there are many different theories. Could it be that the iron content in the Earth and the Moon were locked in during this formation process, be it quick or slow? And this would imply that the Earth and the Moon did not form at the same time or in the same place as Mars. The problem with the first 2 scenarios is that when we examine the iron ratio on Earth, the Moon, and Mars, we find that the Earth and the Moon have very similar high levels of heavy iron, whereas Mars does not. In the first scenario, it would be fair to assume that all the planets are driven electrically, and we should therefore have a similar ratio in all of the planets. It may be possible that Mars is just underpowered, which may explain its lack of a magnetic field, but then the question becomes, well, why would the Moon have a higher level than Mars? Assuming, of course, we don't buy into the scenario that the Moon was formed due to an impact event in the Earth. The second scenario fits nicely with the concept of Velikovsky and the catastrophic events that occurred between Earth, Mars, and Venus. The problem here is that when we examine Mars, it has far more scarring, so we would assume that this took the brunt of the discharge, and therefore you would expect this to have a much higher heavy iron content than the Earth or the Moon. The third scenario could explain a difference between Mars and Earth due to the fact that Mars may not be inhabited by this type of microbe. Explaining why the Moon is similar to the Earth is again harder here, as the migration from the Moon to the Earth would not be easy, but we cannot rule it out. And again, an impact scenario could explain this one as well. The fourth scenario neatly sidesteps the difference, but does not really provide any answers to why this would be different. So where does this leave us? Understanding why the Earth and the Moon have such a similar ratio is important. I personally do not really see the option of a Mars-sized object causing the formation of the Moon, but I can't rule it out. We know that the iron content of the Earth and the Moon are similar. We have physical samples from Apollo, although you could argue that these may not be lunar samples and could equally be ejected material from Earth or other meteorites. They are all surface collected. We have meteorites that we assume have come from Mars, which show a lower level, but no samples directly from the surface or below the surface of Mars. We also have no readings for any other planets at this time. So how much do we really know about the distribution of iron throughout the solar system? We know that a small fraction of the meteorites have high levels of heavy iron like Earth, but the majority do not. We know that the heavy water ratios on Mars and Venus and the comets are the highest. Earth sits somewhere in the middle, and then the gas and the water giants have the lowest level of all. We have a mechanism for creating heavier isotopes through electrical discharge, or even microbial life, and maybe it's a combination of both. These are all clues as to how the planets form and what happened to our solar system in the past, and may well happen again in the future. This is the tip of the iceberg and provides many questions with few answers. We need to follow this trail to see where it leads. As always, be brave, be curious, the truth is waiting for us. Until next time.